So in this video, I wanted to talk to you guys about standard deviation. Three things I wanted to point out was number one, what a standard deviation is. Two, how to calculate it by hand. And then I wanted to show you how to calculate it using your calculator because that can kind of get messy sometimes, especially if you have a large data set. So first of all, what is a standard deviation? The standard deviation is just another way to tell us how spread out data is. So in a previous video that I made, we talked about the 5-number summary. That tells us how spread out a data is. It tells us the min and the max. So it tells us the range, and it tells us how the data is broken up into 25% chunks and where most of the data lies. Now, with a standard deviation, rather than have 5 different values like in the 5-number summary, the standard deviation is one value, and that tells us on average how far away a data value is from the mean. So I have two graphs here. Here's one distribution, here's another distribution. This one here is going to have a larger standard deviation, and this one here is going to have a smaller deviation compared to this one, because if you notice, on this one here, the data is kind of centered around the mean, and it's hugged in a little bit closer to the mean. So that means on average, the data values are closer to the mean, which means it has a smaller distance from the mean. Versus the larger standard deviation, if the data is more spread out, your standard deviation is going to be bigger because that means on average, you're going to be farther away from the mean. Now, there's two formulas you'll need to know. If you're calculating your standard deviation based on your entire population. So if I have a data set that that I've collected from my entire population, I want to use this formula here. If I don't have access to my entire population, which is usually the case, we usually take a sample, and then if we have a sample, then we're going to use this formula to find the standard deviation. Now, what you would do, this symbol is summation notation, and what that means is you take each data set and you subtract it from the mean to find the distance from the mean for each one. Then you square that distance. This summation notation tells me once I do that for each data set or each data point, I add up all those values. Then I take the sum of those values, divide by the number of values I have, and then take the square root. So for the sample, it's pretty much the same thing, although when you take the sum of these values, you divide by one less than the number that's in your sample. So if I had 10 data values that I was doing this for, I would divide by 9 because that's one less. With the population, you divide by the number of values you actually have in your data set. If it's a sample, you just divide by one less. Okay, so here's how we're going to do this. Here's an example. We have 10 test scores. I want to find the standard deviation, and these test scores are a sample. So I maybe want to find out about test scores for an entire school, but maybe I randomly selected just 10 test scores to find this information out. So because of that, I'm going to use the standard deviation for a sample because this doesn't represent the entire population. So the first thing I need to do is I need to find the mean. So I'm going to add up all these values and I'm going to divide by 10. That will give me my mean. Okay, once I find my mean, I need to find the difference between the mean and each test score. So I listed all my test scores here, and then I found the difference, and I don't care about the sign because when I square it, whether it's negative or positive, it will become positive. So I just want to figure out how far away each of these test scores are from the mean. So I take 66 minus 22, that gives me 44. I take 99 minus 66, that gives me 33. I'm just finding how close these are to my mean 66. I'm finding the difference, so I'm subtracting. That gives me all of these values here. Once I get all of these values here, then I have to square it. So this is why I don't particularly care about the sign here, because when I square it, it's going to become positive. So I take 44, I square it, and I get 1,936. When I square 33, I get 1,089, etc. And I do that for each one. Then the summation notation tells me to add all those values up. So I get a sum of 8,338. Now, because we're using the formula for the sample, that's this one here. So far what I've done is this part right here. I've added up the square of the differences from all those values. Now I have to divide by 9. Since I have 10 data values, I'm going to divide by 9, and then my last step is to find the square root. When I divide this by 9 and I take the square root, I get that my standard deviation, this is the symbol for standard deviation, is 30.44. Now, so this means on average, if I randomly pick one of these data values, on average, not exactly, I'll be about 30 points approximately from the mean. Now, on your calculator, it uses SX for sample standard deviation. So that's what I want to show you next, how you can do this on your calculator. So we're going to put all of our values in the list. I'm going to turn on my calculator and I'm going to hit the stat button. I'm going to go to edit and I'm going to put all my test scores into list 1, and I've already done that here. But if you want to do that to kind of follow along, just pause the video and go ahead and put in all your test values. Once you put in your test values, then you're going to hit the stat button. I'm going to arrow over to calculate, and I want it to tell it to do one variable stacks, and I want to do it on list 1, so I want to make sure I have list 1 here. If you have a different model and it comes up one variable stacks in words, you just hit your L1 button like in the previous video that I showed you. You hit second L1 to tell the calculator you want to do this on list 1. And I tell it to calculate. And here you can see I have SX. That's my sample standard deviation, which is what we just calculated, 30.437. See, we did that here. I rounded to 2 places. If this was my entire population and I used the other formula where I just divided by n, that is this one right here. That's the sigma x. That stands for the population standard deviation. So, but typically we're going to use this unless we have the data set for the entire population. So this, doing it on the calculator is obviously a lot easier than trying to do this out by hand. This was 10 data values. Imagine you had 100 that you had to do this for. It wouldn't be hard, but it would be very long, very tedious, and very likely somewhere in there you would make a small arithmetic error with that many data values. So I would suggest that from now on, now that I showed you the difference between doing it by hand and on the calculator, that you just do it on the calculator, and if it's, remember the difference between the SX and the sigma x, this is your sample standard deviation, and this is for the population.